we go. Last week of homework before spring break. Woohoo! March the 10th, 11th, and 12th. For Bailey, Henderson, Jakovich, and you remember from last week, it's not Losi anymore. It is Miss White. Okay, moving on. Problem number 2 on Monday. Mr. M has 15 girls and 10 boys in his first period. He puts each student's name on a popsicle stick and puts the sticks in a container. What is the probability of Mr. M drawing a girl's name out 2 times in a row if he randomly draws the popsicle stick, does not replace it in the container, and then randomly draws a second? Okay, let's look at this problem, what we have going on again. So for his class, he has 15 girls. So I kind of drew a picture of a cup over here, like his popsicle sticks are in this orange cup. He has 15 girls and 10 boys. What that means is he has a total of 25 students all together in his class, all together in that cup. Okay, he's asking about the probability of drawing a girl's name out 2 times and not putting it back. Okay, now we got to remember every action multiplies a fraction. So his first action number 1, he wants to know what is the chances of him drawing a girl's name out. Right now, I know there are 15 girls. 15 girls in that cup out of a total of 25. Now the key here is he does not replace it. So that means he's taking it out. So instead of 15 now, we only have 14. And that means also there's not 25 anymore, there's only 24. Excuse me. So his second action, he wants to know what's the probability of drawing a girl on the second time? Well, now there's only 14 girls. 14 girls out of 24 this time. We've got to remember every action multiplies a fraction. So I want to multiply. Remember, multiplying fractions make them big, so I want to see if I can reduce. I know I have 15 and 25. 5 goes into both of those. 5 goes into 15 3 times. 5 goes into 25 5 times. Times. Now look at the other ones. Well, these are both even, so I know I can definitely cut them in half. Half of 14 is 7. And half of 24 is 12. But remember, I can reduce any top with any bottom. 3, 5, and 7, those are all prime numbers. But I can reduce the 3 with the 12. 3 goes into 12 4 times. So 3 goes into 3 1 time. So 1 times 7 is 7. And 5 times 4 is 20. So my answer here is 7 out of 20. Moving on to Tuesdays. Linda owns a candy store and decides to put her fudge on sale. Her fudge costs 75 cents per pound or part of a pound. This situation can be represented by the equation. If Belinda charges $8.25 for her fudge, how many pounds of fudge did Chris purchase? Well, this is a question that's a little bit easier to you. It also gives you the answer. So it's telling us the cost. So this problem's where we're going to have to work backwards. Okay, you know how lately we've been writing ESS, equation, substitute, solve? Well, this is my equation. My next step is to substitute. I already know the cost is $8.25. So instead of putting C, I'm going to put $8.25 is equal to 0.75. Remember, no sign means to multiply. So 0.75 times the pounds. And that's what it's asking me to solve for. Well, they are multiplying to get 825, so you have to work backwards. The opposite of multiplying by 0.75 is to divide by 0.75. And that way what happens is they cancel each other out and you're left with just the P for pounds. But if you do it to one side, you have to do it to the other. So on this question, I'm doing 825 divided by 0.75. When you divide, your numbers are actually getting smaller. So I know my answer can't be anything bigger than, I'm sorry, I started saying an incorrect statement. We are dividing by less than a whole, so your answer is going to be even more because you're taking part of a part. You're taking small pieces, and you can always break things down into small pieces. I got to move my decimal to my wall. 1, 2. If I do it to the outside, I have to do it to the inside. So here's my new decimal. 75 can go into 82 one time. 75. Please pause it and try to divide it out for yourself. Okay? So borrow, that's 7, that's 12. So I had 7 left over. Bring down my 5. And 75 goes into 75 one time. So my answer is 11 pounds. Okay, moving on. Wednesdays, which equation can be used to graph the line below? Ah, this one's a piece of cake, guys, because look at your graph. Your graph gives a big hint away. Right here is our origin. Since it does not go through the origin, we do have to add or subtract something to it. So my answer cannot be B or C because I have a constant. If I wanted to, if you don't believe me, try this one in that place. 5 times 1 is 5. So the point would have been about right there. Okay, so that's not going to work. This one was -5, so -5 times 1 is -5. Since that's -5 and it's 1, it would be somewhere down here below. So it can't be those two. All I can do is take it and plug it in. If this is 5 times x plus 15, so I want to say 5 times 1 plus 15. 5 times 1 is 5 plus 15 is equal to 20. So if I have, this is my x, this is my y. So if I have 1 hour, I'm going to be equal to $20, and that fits the line perfectly. Over here, if I plug in the 1 for my x, that should be -5 plus 15. Remember, what happens when I have a positive and negative? They're opposite, so they cancel each other out. I really have to subtract, and I would have gotten 10. So that means if I was doing this problem and I had an answer of 10, it would be 1 and 10 right here. It does not match, so my answer can't be D. Okay, I'm going to take a look at another problem. There's a mistake in this, so we don't have an answer there. Okay, there's a typo in this problem, but I think we need to look at it because it's a good problem to look at for star being so close to us, okay? Here it is, picking out an equation from the table. I wanted to remind you, your position is your x, and your value of your term is your y. Y always depends on what x is. And one new thing you learned this year to help you with that is delta. And you remember us adding to our table? We found our delta y, and we found our delta x. Remember, delta meant change. Delta meant change. How did it change? Well, looking at this is a little bit hard to compare because this has 2 places. This only has 1. So let's add a placeholder there. And then back to 2. So from 25 to 50, think money. it went up by a quarter, so it went up by 25. Here, it only went up by 1. So delta y is your change in y, which is 0.25, over 1, which means 25 divided by 1, which is equal to 0.25. That means that is my coefficient. Remember, coefficient cannot be a lot. That means we have to be multiplying by 0.25. Here, they're not multiplying by anything, so A could not be my answer. Here, they're multiplying by 4 when it should be 0.25. That's not the same. Here, they're multiplying by 1/5. Well, we don't know about this one, okay? And here, they're not multiplying by anything. So A and D should have been the first two answers you get rid of because they're not multiplying by anything. Okay, B is multiplying by n and C is multiplying by 1/5. 0.25 is a decimal. How can I convert 25 to a fraction? That's 25 tenths, hundredths. 25 hundredths. 25 hundredths, or think a quarter. How many quarters go into a dollar? That's 1/4 out of 4. So I can either multiply by 0.25 or multiply by a fourth. So our answer is not here. I bet it was supposed to be C and we had a little typo. So our answer here is going to be 1/4 times n. The only reason why I wanted to show you this problem is to refresh your memory about our delta y and delta x. For those of you who remember how to do your delta y and delta x, that gave you your coefficient, and that's what you always multiply by. So we could either have 1/4 times n, or you could have seen the answer choice of 0.25 times n. Now you can plug that in. You might have to add or subtract. Here, we didn't have to do any of that. It's just 1/4 times n. Thank you for tuning in this week, and enjoy your spring break. And we'll be back for one more week before STAR.